We're ready to get started then. So, hi everyone, appreciate your patience and welcome to this webinar on solving the challenges of electrical complexity. Today we will present on multiple areas, but primarily focused on electromechanical design workflows. We'll be covering a majority of issues on how to avoid things that are going wrong or things that could be improved when it comes to your electromechanical workflows, and in particular, really be focusing in relation to vehicle electrification. We're excited as we'll be hearing directly from one of our clients, the Innovative Vehicle Institute, on how they've tackled such challenges. And we do have a great group of co-presenters who I'll be introducing shortly. But before that, I just wanted to start by sharing a few housekeeping items. First and foremost, this will be an interactive webinar where we will be having short polling questions throughout. So we look forward to your input. On top of that, if you have any questions as our presenters are going through their specific slides and areas, please don't hesitate to ask them in the question feature of GoToWebinar, and we will aim to address them either at the end, during if it comes up as part of the presentation, or by connecting with you afterwards if we run out of time. Please also note that the presentation material and the recording will be shared by email as well. So with that, we will get started. In terms of introductions, my name is Daniel Mazzara and I'll be your host for this webinar. I'm responsible for customer success and sales operations at Maya HDT. I'll be introducing Maya shortly, but I leverage my electrical engineering background in supporting clients across North America on complex engineering and digitalization challenges. Very happy and excited to be here with you. Next, we have my colleague, Mohammed Omer. He is our technical pre-sales engineer for electrification needs. Mo has years of experience with a variety of electrification tools, whether we're looking at integrated electrical systems, electromagnetics, ECAD, and on top of that, he is consistently appreciated for providing immense value to his clients and his peers alike. Mo also works at Maya HDT. Again, I'll be introducing Maya in just a couple of slides. With that, we also have a few esteemed colleagues joining us. Next, I'll introduce Benoit Desgenais, or Ben, who is the lead technician at the Innovative Vehicle Institute, or IVI. Ben brings over 20 years of experience in the transportation world. He is a specialist in wiring harness design, prototyping, and manufacturing. At IVI, he leads the technical team supporting the engineering department, and he also co-chairs the Electric Mobility Cable and Interconnects, Visual Acceptability and Process Requirements group that will soon be regulating the manufacturing of electrical vehicle components. We're very excited to have Ben with us here today. And last, but definitely not least, we have Paul Johnston. Paul is a portfolio development executive with Siemens Digital Industry Software, specializing in integrated electrical system solutions. Paul also brings with him over 2 decades of experience and has contributed to technical articles in various US and international publications on the theme of software-driven improvements from architectural design through manufacturing assembly of complex electrical systems. We're happy to have him as well as he shares his wealth of knowledge with us. So we'll be going through and having sections presented by this great group. And again, as you have questions related to them, please don't hesitate to shout right in the question panel and we'll address it either as a group or with the individual panelists. Great. I also wanted to mention that this is the first webinar in a series of webinars that we are conducting on vehicle electrification. And it's quite exciting, and you should have received the invite for the whole series. Today, we'll be talking about electrical complexity, in particular focusing on integrated electrical system solutions, but we do have follow-up webinars that are happening next on e-motor performance degradation due to demagnetization. Over there, we'll also have a co-presenter with us, Professor David Lowther of McGill University, co-founder of Infolitica and the Magna and Motorsol product lines. So that will be an exciting webinar as well. From there, we'll get into talking about component sizing and subsystem integration within full vehicles. Again, a very interesting topic with some great subject matter being brought to the attention. And finally, we have a 4th session that will be happening that will be based on your input. So as we're going through the series, we'll be asking you what else you'd like to see what you're interested in, and based on that, we'll give you a heads up in about a week or so before and saying, hey, this is what the last session will cover, but please feel free to go ahead and forward it to your colleagues. You may note that this is an invite-only series, but as attendees, if you're inviting someone else, just send us a note and we'll aim to accept them as well. As again, we'd love to share this information. We just want to make sure that it's relevant to the audience that's here in place. Finally, with this webinar, once it's in your calendar and you've registered and been accepted, it will be in your calendar for all 4 parts of the series. So we'll look forward to seeing you in the other sessions as well. Great. Oh, excuse me. Oh, apologies, we seem to having some slight lag on my end. There we go. As I mentioned, this webinar series is brought to you by MyHDT. That's where I work along with Mo. Maya is a leading provider of digital engineering solutions and the #1 global partner for Siemens Digital Industries software. Our history is in aerospace, but we have been working diligently within multiple industries on complex engineering challenges for the past 3 decades. In particular, there's been immense growth that we're seeing around the challenges and adoption of software and cutting-edge tools when it comes to vehicle electrification. And we're excited to be working with clients all across the world, but in particular in US, Canada, and the UK in relation to this domain. Today, we're covering only a small subset of our expertise and knowledge base, but again, it goes beyond electrification and beyond integrated electrical systems. This is just a small example, but one of the areas we're working on goes into helping companies create their own digital twin representations of physical models. This could be either in the design and prototyping phase in manufacturing or even out in the field. In particular, we're seeing tremendous interest in AI applications, being able to capture data related to something that is active in the field and turning it into valuable information through our knowledge, algorithms, and technology. The knowledge we have of industry best practices does position us very well to support our customers in achieving those goals. So this is just that, there's a lot more that we can talk about. And if you have questions in these other areas, don't hesitate to reach out to the people who invited you to this webinar series or send it directly to us afterwards. But again, today we're really going to be focusing in on electrification and integrated electrical systems. So with that, I'm going to go ahead and pass it off to my colleague Mo, who is going to bring us through the next section of the presentation. Thank you.
Thank you, Dan. Thank you very much. Hello, everyone, and welcome to the series. My name is Mohammed Umar, and in this presentation, we will look at solving the challenges of electrical complexity. To start things off, this is a brief overview of what we're going to cover in this presentation. We're going to start by discussing the evolution and how that is impacting the electromechanical design and the wiring and electrical complexity. From there, we're going to pass it along to our colleague, Paul, to talk to us about digitalization, digital twins, and how we can leverage digitalization in solving electrical complexities. Also, we're glad to have Mr. Benoit from IVI, who's joining us today. He's going to talk to us a little bit about IVI and what they do and how they leverage the tools that essentially provided to solve the growing electrical content. From there, we're going to discuss VSys, which is the tool that we're going to be focusing on today. We're going to jump into some of the functionalities and how we can leverage those into addressing the challenges in the electromechanical design. From there, we're going to summarize what we covered so far, and we'll open the floor for questions if there are any. We all have read about and witnessed multiple advancements. Some are slow and some are incredibly fast. Getting on board and leveraging these advancements can make or break a company or a technology. For example, this is a photo that was taken in the early 1900s on Fifth Avenue in New York. What you can see here is that the whole street is filled with what was then acknowledged the method of transportation is the horse and carriage. But if we look closer, we'll find that there is a new kid on the block, which is a car. highlighted in red. Now, is that car the most efficient mode of transportation in that ecosystem? Probably not. However, if we look at the same street, only 13 years later, there is but a single horse and a carriage on the street. In only 13 years, cars went from a nice to have to an essential part of that ecosystem. And what happened to the horses and carriages and the manufacturers and suppliers for that specific industry? Now, of course, the evolution continues. And this, what we've seen previously, was almost a century ago. Does this hold true in our timeline? This is a picture from St. Peter's Square in 2005 during Pope Benedict's inaugural speech. Notice at the right bottom corner of the picture, there is a person with the latest technology. It's a Motorola flip phone. Again, not exactly sure if the quality of the picture or recording is worth the while. However, it's a new technology. It's a flip phone nonetheless. Now, we're going to look at the same ceremony, but only 8 years later. The little cell phone is now everywhere. But there is a new kid on the block, though, and that is the tablet. And once again, I question its utility back then in 2013, but if you've ever taken a road trip with kids, you definitely appreciate the value of a tablet. Now, we can observe the evolution in all faculties of life. So it's no surprise that the automotive industry is growing exponentially, and so is the technology. For example, this is what a luxury car used to look like in the early 1980s. And this is what they look like today. We see digital screens everywhere, different types of sensors, from parking sensor, cruise control, radar, and so on. The evolution is increasingly faster to the point where, on average, for a modern vehicle, the wiring harness is the heaviest component after the engine and chassis. And of course, this evolution is reflected on the electrical wiring and harness design. For example, according to BMW, there are over 50 million configurations available for the BMW 1 Series. And if we look back again in the early 1980s, this is what a simple wiring harness looked like. But because of the evolution, this is what it looks like today now. This is a wiring harness of the 2019 Bentley Bentayga. And this applies to all industries, that the challenge of more complex harnesses and electrical distribution systems is all over. Therefore, the electromechanical design in modern products is extremely important. And at this time, I would like to pass the control over to our first speaker, Paul. Paul will take us, will talk to us about digitalization and digital threads in electromechanical design. Paul, please take it away. I'm going to give you control over the screen. Paul, can you hear me?
Yeah, I can, Mohammed. You can hear me?
Yes, sir.
Oh, excellent. Thank you very much, Mohammed. That was thought-provoking. Let me see. All right. That's my name. My job is to make sure that customers of Siemens Digital Industries who use the integrated electrical system software are generally choosing the right thing for their needs, and after they purchase that, they remain happy, contented customers who take the upgrades and so on. As you can tell by my accent, I'm based in Detroit, Michigan. I've lived here for about 20 years, and I'm very privileged, I think, to be invited by Maya to present. Maya are a very valued channel partner of Siemens, and all of us who work with Maya are very impressed with their capabilities. What I'm going to talk about is some of the concepts and some of the realities of the VSys software. But first of all, I want to draw back and talk about the concept of digitalization. lists like these of the benefits and the outcomes, and I think the outcomes, what's in it for you on the right-hand side, is more important for you to concentrate on. These are familiar, but the reason I'm showing them is that we at Siemens understand that for electrical engineering and for people that design electrical interconnect, they've been rather poorly served by information technology tools over the last 15, 20 years. Generally, if you digitalize, you go through a process of shifting your understanding and you begin to pivot your design process. What I want you to understand is that these days, you can expect as an electrical engineer, best-in-class tools to give you three things. First, they can instill you with confidence that you're doing the right first time because they will guide you on the path of correct by construction. Secondly, you can expect that your engineering knowledge will be shared between the other stakeholders in your design. Now, if you happen to be the sole electrical engineer, it means that you should expect the tools to give you opportunities to collaborate. And then the third thing is you should realize that tools these days aren't just turbocharged CAD drawing systems. You should expect the tools deliver to you decision support activity. Dan mentioned a term, digital twin, and I think it's worth just spending a minute or so understanding what we in the technology efficiency tool side of things mean when we talk about these two concepts, digital twin and digital thread. So first of all, digital twins are models which are used to predict or reproduce performance or behavior. Sometimes people talk about the digital twin of project, the digital twin of performance. For example, if you design an electrical interconnect system, you may want to simulate the electrical behavior, test for voltage drop, and so on. A simpler example may be you want to put enough fidelity into that model so that you understand a certain area of the harness is in a wet area. Therefore, you can have the system automatically choose plugs and seals for the cables that are putting connectors. So, on digital threads, the reason you set up digital threads, which address workflow continuity issues in the way you work, is to take advantage of being able to generate results rather than do manual interventions. When you set up a digital thread concept, you look from the point of view of collaboration. You study the origination, the consumption, and the sharing of data. Now, digitization that I talked about at the beginning, people refer to these two concepts. We'll look at them in turn just very briefly. A digital twin typically looks something like this. It looks like a 3D MCAD model. And the reason that you do a 3D MCAD model is for practical purposes, like you might want to change some components in the CAB area and see whether you conflict with the space available. For a digital thread, people express it. Here's a relatively simple one. People express these usually in diagrams. So a central data repository where you tap into that resource to draw electrical schematics or wiring schematics. And then through a process of normalization and reuse of the data, later on in the design cycle, the same information can appear on a harness spring. a one-to-one harness print or a non-scale harness print. And both visualizations or both abstractions of your design can interact with another domain through adaptive bridges. In this case, a simple representation of an MCAD system. So that's an example of a simple digital thread. Let's just take a look at what it looks like not to have a digital thread. Like I said, electrical engineers have been traditionally poorly served for advanced tools. And it's by no means unusual to see non-specialized tools. Nothing wrong with Visio, nothing wrong with Excel. However, electrical engineers usually end up disappointed because there's no underlying intelligence or associativity. And any changes that ripple through your designs, if you use those two tools, you have to painstakingly follow through the change and check lists of things. Specialized tools also have the potential to disappoint. If you have a specialized drawing tool just for drawing activity instead of design, then you could run into problems with change management again for engineering changes. The drawing is not itself the model, it's a manifestation of the model or a representation. So something that can manipulate a drawing just maybe manipulating a representation of the drawing rather than a model with fidelity to the underlying nature of the design. So using suboptimal tools is no longer sustainable for complex designs, for big designs, for designs which change quickly, or huge projects of design. And systems like VSys enable you to cope better with those challenges. And from really the kind of molecular level upwards, I'm showing in the database, customers like IVI model first the individual symbols for devices and interconnects. And then the library data models enable you to model complex multi-conductors. This is by no means the most complex that you can model, but you can see it's foil wrapped, it has a twisted shield, a jacket, and I think there's 6 conductors in there. Knowing the difference in your design as to the different cut lengths or the different terminations of these inner cores is something that a specialized tool really should deliver to you. Here's a modular connector with different size pins, different inserts, and so on, and very many permutations possible. So the underlying library model, even with simple mechanical parts like tapes and tie straps there, is an important component of getting the schematics that you're authoring to pass the design rule checks so that you have quality assured. There's a substantial amount of design rule checks built in. And then once you have the schematic passing the quality checks, you do simulation. The green here shows the current flow. So there's a simulation capability in the VSys tool. Mohammed's going to show the functionality in a little more detail. One of the things I want to talk about, referencing back to the digital thread aspect of VSys, is this is a couple of screenshots from inside of the harness part of the tool. And you can see that there's text messaging or team collaboration opportunities. Courtesy of the Institute of Vehicle Innovation, they allowed us to disclose a little bit about the pattern of usage that they have of VSys. The icons represent different specialisms within their team. The chief technician, a librarian, engineer, and a technical specialist. IVI maintain a separation between people that produce the CAD drawings and the engineers. This is a seniority and specialism demarcation that is quite common. One of the interesting things about this workflow is that it is particular to IBI. There are a number of other VSys customers that I have worked with who make their engineers responsible for the drafting, the verification, and the modification of their own drawings. It's an indication of how VSys can be flexible in the way you deploy it into your own organization. The other thing I want to draw your attention to are the darker arrows, where there is a meeting and a task handoff, or a progression from one stage of the life cycle to another. With VSys and the functionality in VSys, IBI will find that this doesn't have to be a formal meeting. It can now be a much more fluid, organic, and continuous process. The interaction, even in an era where everybody's working from their home office, is facilitated in an advanced tool like VSys. So let's just revisit that straightforward digital thread. I've marked up a few of the practical consequences of using this advanced tool. If you take away one thing, I want you to take away from Mohammed's exposure of some of the functionality, how intensely practical your experience of using VSys can be. It is a system that hasn't grown out of a mechanical CAD suite of tools. It's been purpose written for electrical design. Therefore, you can expect the experience of this system just understanding your engineering challenges. If I can get it right. The summary, I just want to say three more things about VSys. That VSys is a mature software suite that's been proved out the last decade by customers literally around the world. The consistency of data handling with the sophisticated domain-specific models that we talked about, the digital twins of the elements of your design, make it a really comfortable recognition and familiarity of the things that you see in the functionality as you learn the tool. And finally, the advanced automation that's possible is one of the more pleasing aspects, I think, for IBI as they've gotten into using the tool. They realized that what one customer called the gritty, repetitious manual tasks that they had to do fade into the past and are no longer part of your design activity. Thanks, Mohammed.
Thank you, Paul, for the amazing presentation. So, unfortunately, evolution is one of the side effects of a common industry trend. Electrical content is always increasing regardless of the industry and the application. This increases the overall design time due to the complexity, and also increases the cost of the initial design, increases the time of the cost due to the complexity, and similarly, every time something new is added to a design, the chance of inducing an error becomes along with the change and becomes greater. Now, to learn more about how VSys addresses the impact of growing electrical content, I'll transfer the control to our second keynote speaker, Mr. Benoit, Ben, I'm gonna make you presenter,
Thank you.
and you can control the presentation.
Can you hear me, Mohammed?
Yes, sir.
Awesome. Thank you. Hi, everyone. Thank you for being here. I spent probably a couple months with Mohammed and Paul initially when we first decided to go with the VSys software. And I'll show you a little bit of what where we come from and what we've done so far. IVI, just to present for some of you that don't know who we are a team of engineer that helps customers bring their business, bring their innovation and new project, new electrification of their vehicle all the way to production. We are what we call the CCTT, so Technology Transfer Center of the Cégep de Saint-Jérôme, which is a college, and we are part of the Natural Science and Engineering Research Council of Canada. We do have over 20 years of experience in electrification. Projects come from as far as the CEVEC back in the days, and then moved on to ITAC, l'Institut du Transport Avancé du Québec, from the college, and starting with the ZEN. And then one of the good projects that we've done in the past, something that we're really proud of, is the Lion Electric Bus that started from very early prototype of the electrification, the drivetrain, and then complete design of the battery pack. I personally spent about 6 months on the shop floor helping the team at Lion get their initial prototypes of the assembly line. Here are some of the customers we work for, some names you might recognize. We've got customers from around the world, worked with customers primarily in Quebec, but then some in the US. We've got customers in Germany and France and Brazil, Mexico for different projects. Paul did explain a little bit about how we work with VSys, with a customer, and how we gather the information in order to do the wiring schematics and wiring design. So I highlighted some of the parts where we work primarily with VSys. So for example, on point number 3, the detailed design, we do all the wiring schematics and harness design at the same time as the mechanical design that will go in conjunction. And that's where the VSys software is really interesting, where we can mix the electrical CAD with the mechanical CAD. The VSys software helps us as well when we do the form board. So we do the schematics, harness, and then in the end we'll do the pegboard or the form board, where we can do actual harness assembly in-house. And that was part of the reason why we chose the VSys software, is that it is an absolute seamless process to go from schematics and then to harness, and then at the end to have the form board and do the actual work. We do as well the review and the per build correction, which are easy to do with the VSys software compared to the tools that we had in the past. And at the end, part of our mission is to transfer all the data and all the information gathered during the design and the project. Yeah, the VSys software is easy to customize. I'm showing just a cartridge here, but things that are sometimes very complicated and older software that's been worked on because they started as a mechanical CAD software and then going to electrical CAD, it makes life more complicated and difficult because it's not a seamless way to work. It's a different way of thinking because it's a patch, and instead of being a software built from scratch. There's the library, I think, is the very, very important part of the software. The way it's been built, it enabled us. I'm showing an example here where we had a contactor here that has an optional part. So in order to build it in the library and have it as an option when the schematics will be done, it's something that we've never been able to do in the past, and we had to do like manual black box. It wasn't always easy to control in the schematics, and then when going into the harness design, it was an absolute mess. So I'm showing this to give you an example of the possibilities of the library. I'm also an IPC A620 instructor, and also I've teach the here at the college the D620, which is the harness design, and that brings me to all the information that we need from the software. Because when I teach the students at the college about wiring design and wiring assembly, you need as much information as possible on the drawing. And we've been able, just like Paul showed earlier, you can have notes from collaboration in between different team or different people in the team working on the same drawing. It's a very, very easy way to work. One more thing. This is an example of a new electrification, vehicle electrification connector. It becomes very complex. It's got multiple parts, and this is one thing that we couldn't do in the past, is have all these parts work together in the library. So when you select one part, every other little component needs to be attached, and it needs to be selected in the bill of material. And we had some issues in the past when using, older software or Excel spreadsheet and Visio, like Paul was saying. This is some of the tools that we use in the past, and we had some problems and mistake. Now with the new tool, going from schematics to harness design and form board, I've been able to verify that there's actually no parts missing. Yeah, I think that's yours, Mohammed, isn't it?
Yes, thank you very much, Bernard, for your time and the amazing presentation. Thank you very much. Now let's take a deeper dive into the tool Ben, Paul, both of them were talking about, which is VSys. And we're going to break down VSys into 5 main categories. We'll talk about how VSys helps you maintain an up-to-date component libraries, as well as establishing the links between those components. And just as Ben mentioned, it's extremely important to maintain your database. And from our experience and from Ben's experience, VSys helps streamline the process by creating those links into the components and the components libraries. And of course, once you completed your first design, you'd need to validate your design. And we'll discover how we can validate your design with different simulation tools available off the shelf with VSys, in addition to tracking and exchanging notes and comments between the different engineers and technicians teams working on the design. And of course, electrical engineering is inherently a multidisciplinary. You have different teams, different technicians, different engineers working on the same project. Integration must be provided in order to make sure that all the processes, all the documents are consolidated. And VSys is built to integrate through data exchange with adjacent domains using industry standard formats. And of course, electrical design, optimization, verification, and engineering is now only feasible using an integrated data-centric tool delivering substantial automation. Error and insufficiencies are avoided, and engineers are free to essentially solve their design problem. VSys digitalizes the electrical domain and creates the electrical distribution system digital twin upon which unique automation is delivered, reducing development cost and cycle times for more functional products. And finally, we'll discuss the native reporting faculties and functionalities in VSys, as well as building and customizing user reports. So let's start by component links and component maintenance. And before we jump into the tool, let me just quickly ask you guys a poll questions, and then if you could be please kind enough and start the poll for the attendees.
Perfect. I'm on it, Mo. Again, while I'm getting that set up, really appreciate the excellent presentations thus far. So I'm going to go ahead and launch the poll. It's similar to what you saw. As I mentioned, this will be an interactive webinar. Very simple. Have you ever created a wiring design with two connectors having the same name? It's yes or no. We'll give you about 20 seconds to go ahead and answer. So please, if you could get that going, great. I see the answers are trickling in. Perfect. Great, we'll give it just a couple more seconds now. All right. Great, thank you all. Mo, just so you can see the results, I'm quickly sharing them. So based on the audience input from those that filled out, 16% said yes, while 84% have said no. So the majority of the audience has not created a wiring design with two connectors having the same name. And with that, Mo, I'll pass it back to you.
Thank you very much, Dan. And it looks like most of the attendees and 80% of the attendees are doing an amazing job. And we're here to help you even do a better job. So, of course, having the same name in components, connectors in a design is something very common that can happen by mistake or can even happen just without knowing, by having essentially two engineers working on the same design and not having the proper communication channels. And this is very exceptional. This is very common. So what we're trying to do is to talk to you about the component maintenance in VSys. VSys is designed in a way that you can update your database and your component database by essentially making it easier for the user to update, by simply dividing the way you enter the data into the database into three main components. You have your companies, where essentially you have a list of all the customers and suppliers that you deal with, their information, addresses, part numbers, and so on. You have the codes. The code section is where you define the codes that you use and utilize in your own company. And this is where the flexibility comes in. You're not limited to the default codes. You can have your own color codes, your own material codes, essentially to customize the tool to match your design standards and your design formation. And of course, the last thing is the components, to manage the components themselves, to add new components, create the links between the components, and essentially to cover the link between all the components that Ben was talking about. So the idea is, by establishing those component links, the user would be able to extend the digital thread from the components database all the way to your design. So VSys is not just a drawing tool. Just like Paul mentioned, VSys is the tool that represents the design behind the drawing, the fidelity of the design. So by utilizing these component links, you'd be able to link those components and utilize them once they are established into the database. So now let's jump into VSys and quickly build a system and show you how component links work. So I'm sharing my screen. Can you see my screen now, Dan?
Yes, I can.
Perfect. So what we see in the screen is a simple system that consists of a battery feeding power into a lamp, and just we have our two chassis, of course, as grounding. We can see that, of course, if we open one of those components, if we just look at the lamp, we can see that there is no library part assigned to the component. So what we're going to do is we're going to create a new library part, assign it to the component, and establish the links and see how we can tie it back to the design. So we start the component database, and we have the three sections here as shown in the presentation. We're gonna start by opening the components, and we're going to create a new component. By default, the first thing is VSys asks you to provide a part number. So in this case, let's use LMP-1000. And just like that, automatically the name is highlighted in red to indicate that there is an issue with the design. That means there is another part number in the library that has the same part number. So by default, you're protected if you already don't make mistakes by making the same product codes or the same part number twice. Well, this is an extra layer of protection. If you fall in the 16% of the attendees, now this is automatically your first defense line. You're always protected by the design rule checks to make sure that you're not creating components that have the same name, have same part number, and so on. So we're going to change the part number, LMP 1001, and the group name, we're gonna create a device and click OK. The device, we're gonna give it a description, call it electrification. The type code is the type of device that we're using. We're gonna go into the codes that we define from the libraries and select lamp, and we have 2 pins in our device. We also assign a symbol to the device. So we're gonna go and add a new symbol. So whenever we use it, we have it there. It's going to be in electrical, and the symbol is lamp. So let's find the lamp, and is the lamp. Apply. Yes. The next thing is, once we created the device, we created the pins and the symbol to be assigned, we're going to use the component links and define a footprint for the device. Essentially, a footprint for a device is all the connectors that could be used with that device. Each device can have more than one footprint, either on it can have one on the device side and one on the harness side. So you can either have external connectors that connect to the device, or you have the connectors inside the device. So quickly, we're going to create one, it's footprint 1, and you can see it automatically detects that the device has 2 pins, X, Y, and so far there is no harness connector added. So we're going to add quickly. We're going to add a part number for the connector. So this essentially tells VSys that whenever we have this part number, LMP 1001, connector C-1333 is always used with it. So with that, VSys establishes the connection, makes sure that the pins are mated, and with that, we have our connector. Now, the device has a connector assigned to the footprint. Now, if we open the definitions of the connector that we just assigned, we're going to notice that even the connector has a terminal assigned to it. So essentially by this, you're maintaining your connection all the way from a device to the terminal, and you can even extend it even more by adding wires and so on. So this is a very smart way to have all your links together in the same design, in the same library. So whenever you use them, you have everything all over, and all the information is included in the bill of material and all the project documentation, as we're gonna see after. So let's go jump back our design, refresh, because we changed the database, open and assign our part number, LMP-101. It tells us what's gonna happen because of the pins, just the names, we accept that, okay. And just like that, now we have our part number assigned. Now this is the part where it gets interesting. We're going to create the harness connector for the device from the database. We're going to leverage the link that we just created. So I'm gonna click the device and we're going to automatically generate the harness connectors. VSys goes into the database, fetches the information, creates the plug or the seal or the connector or whatever, and automatically connects it to the device. So this is a very smart and easy way to leverage the component links in your database and extend the digital thread line from your database all the way to your design and leverage the design in the documentations and so on. So VSys is not just a drawing tool, it's actually a platform that allows you to innovate in your design. So with that, let's jump back to our presentation and continue from there. Perfect. So now, again, from our experience, this is an extremely important functionality because once you set the link once in your design, it's all set now. In your database, you can use it in all your designs, and it's automated, and it saves you a lot of time and effort. So the next step is we're going to look at design management and design verification. Because as we mentioned, once you create your design, you're already protected by the first line of defense, which is the design rule check inside VSys by default, but you always have to double check your design. Maybe there is something wrong in the design. Before we jump into VSys, before we jump into the design verification, let's ask another poll question. And Dan, if you can be kind enough to start the second one.
Yes, Mo. All right. Great. This is another yes/no question that we have going on. So again, if you could just take a few seconds. Does your first prototype always work the first time with no electrical glitches? Yes or no? Again, we're keeping it very simple for today's polling, but this will give us a good idea on who are the wizards on prototyping. We'll give it just another few seconds before moving back to the presentation.
The Michigander says, watch out for the spurious lawsuits. We don't need a recount, I don't think. This is a clear victory.
All right. With that, I'm going to go ahead and close this poll. So again, this one skewed more in a way that we'd expect. I'd say majority of people, like the rest of us, again, aren't able to make it work right away. There's a couple that make it work right away. Good for those people. But Mo, I think this aligns with what you were expecting. And with that, I'm actually going to go ahead and pass it back to you.
Thank you, Dan. Thank you for the poll. Okay, so from the poll results, we can see that no one always gets the first design right from the first time. And essentially, what we're trying to show you here is that we can leverage the tools inside VSys to help us bridge that gap and pull the poll maybe more towards having the design right from the first time. So in this video, the designer, we're going to utilize VSys native collaboration features to complete a design verification. The designer outlines the desired behavior of the components in question. In this demo, for example, it's the light select switch. Based on the position of the switch, different groups of lights are desired to be on. For example, in position 3, the warning lights and the front lights are supposed to be on. Yes, I'm sorry, I had to restart the video again. So as I was saying, the designer outlines the desired behavior of the components. For example, in this case, we're selecting the light select switch. We're outlining the behavior of that switch for the verification team to make sure that it's operating as we intend. And again, for example, in position 3, we have the front lights and the warning lights are supposed to be on. This is the intended behavior. The designer adds the node to the verification team and associates the components in question to the node, making it easier for the verification team to locate said components. As we can see, simply selecting the components in question, and they're automatically assigned to the node. And this node is always attached to the project. You can always access it and have the history of all the nodes in the project. The verification team then opens the node, locates the components in question, and starts the verification process. Based on the node left by the designer, the verification team begins the verification process, testing the different positions, and just like that, quite quickly, the verification team notices an issue with the design. Immediately replies to the comment, assigns the component in question, and suggests the recommended fix. The designer gets back, sees the note from the verification team to switch those specific wires, for example, in this case. And all the designer has to do now is go back to the design and fix the issue based on the recommendation from the verification team. This is very straightforward. All the history is always going to be attached to the project, so you're going to have a list of history change in all your projects and the communication between the different teams. And from our experience, this is extremely important to have this history in the project so you can always see your design trends and make sure that you have an open channel of communication between your design team and verification team. Again, we go back to the main challenge in electromechanical design. It's the ECAD-MCAD collaboration. Usually in the design, you have electrical teams and mechanical teams working together to finish the design. And the nature of the engineering process is that the multiple engineers are working together and they need to exchange data. And therefore, being able to exchange the data between all teams involved is of the utmost importance for a better, quicker, and less risk-prone design. The electromechanical process is divided into three main tasks or three main objectives. You have the schematics, which are developed by the electrical team. You have the actual CAD electrical routing, which is managed by the mechanical team. And of course, you have the harness design, which is the nail board or the form board that is worked on by both electrical engineer, mechanical engineer, as well as technicians. To start the process, the electrical team will create the schematics, send the information of connectors, wires, and cables and everything to the mechanical team. The mechanical team then imports the data, assigns it to the 3D routed application, and sends back the wire lengths to the electrical team. The electrical team uses the information to essentially incorporate it into the design and complete a more accurate simulation on a verification to make sure, for example, the voltage drops are accounted for. And to see how, and of course, this process is repetitive to make sure that you get the design correct. And of course, this process, to show you here in a video, on the left-hand side, we have VSys with a schematic design work from the electrical team. And on the left-hand side, we have the actual routed device or component. We're going to exchange the data between the two by selecting which harness we'd like to select. We'd like to essentially export and read the data. The data is automatically imported into the CAD system, which in this case is NX. However, the data is imported, all the components are there, all the splices and everything. If you have more than one splice or one of the component with the exact same part number, you have to do a manual assignment. However, everything else is done automatically. The wires are brought in automatically and the harness is generated. Now, the importance is once you establish this connection, you can see that you can do an ideal collaboration situation where you can actually cross-select between the two designs. If you highlight a component in VSys, it highlights in NX. If you highlight it in NX, it highlights in VSys. So this way, both engineers can work on the same design at the same time, regardless of the location. They don't have to be on the same machine. They don't have to be in the same building even. It could be different teams on different sides of the country. So this is extremely important. Now, essentially, we're going to send the information, the wire length that are calculated from the mechanical team to the electrical team. Once the import is done, now we can see all the information is brought over into the schematics, and if you click any wire, you'll notice the wire length is added to the design. This is the first part of the workflow. Once the schematic is built and added with the wire length, the mechanical team then starts the process of creating the actual harness. That means sending the data from the mechanical team to the technicians to actually build a harness and the 3D design. So let's see how that process looks like. Again, we have the same setup. On the right-hand side, we have NX. On the left, we have VSys. This is the on the right-hand side, we have the fully routed device with no wires, just the components. What we're going to do is send the information, the routed harness into VSys. And as you can see, we start the process and the data is brought back into VSys, where we can reuse the data instead of building it from scratch. Data reusability is very important. You select, it saves time on both teams. So you select the flattening process, and just like that, you have your 2D flat version of your 3D harness into VSys. And again, the same functionality stands. If you cross-select, you can cross-select different components and make sure that you highlight them together. So it allows for even more collaboration between the teams. Essentially, this is the ideal workflow between the three sections that leverages data and make sure that the data used between all teams and the time is saved between all the teams involved in the design. So that brings us to the automation side of VSys. The automation side and essentially it goes into design synchronization and part number selections, but the idea behind this is to save time and utilize the data that was already created into the design. So it saves you time by not creating the data again. Data reusability is a very strong feature in VSys. So in this case, in this video, what we're going to do, we're going to look at the design. It's the same design that we just verified. We're going to start building the harness. We're going to see that the harness is partially complete. There are still some parts that are not complete in the harness. What we're going to do now is use the automation in VSys to complete the design by using the data that was already created in the schematics, so we don't have to recreate it again. Simply by selecting the devices and the components that you'd like to bring over to your harness, we'll be able to complete the synchronization successfully. And again, making sure that you bring in the correct information, the correct components by filtering them out and making sure that you assign to them the harness that you'd like to synchronize. We're just finishing up adding the components. And with that, we're ready to synchronize both designs. Starting the synchronization that automatically brings in all the data defined in the schematics to the harness. And all we have to do now is essentially just connect the new added connectors to the harness and the bundles. No need to recreate everything. Everything is already brought in automatically, and the data is reused from the schematics. This is extremely important to highlight. You don't need to spend more time on recreating your work. It's already done. And all you have to do now is connect your essentially components into their locations on the bundles. Once all the components are added, you finish customizing your bundle based on your design requirements, your standards, and your company standards that you'd like by manipulating the bundles easily, as you can see, quite easy and straightforward. The next step, once we have the missing components, we're going to start by assigning part numbers for the wires inside the design. We're going to leverage the automatic design assignment. The part numbers are automatically brought in from the database, leveraging the links that you established in the first place. Then we're going to move to leverage the automation and automation to calculate the wire length automatically. With one click, all the wire lengths are calculated, part numbers assigned, and the same process extends even further by assigning the housing components and the cavity components of all the connectors automatically, either by doing it for a particular component one by one, or leveraging the automation automatically to assign it for all other, excuse me, for all other connectors. And with that, essentially, we open the we leverage the automation processes and functionalities in VSys to streamline the design process, to streamline the design stages, and reuse the data that's already available in the schematics and the 3D routed application. And the last part to highlight is the reporting. The reporting is extremely important because we need to think about how much time do we spend creating design documents such as bill of materials, wire list, and part list? And how do we share these documents, and how do we customize such documents as needed? So let's jump back into VSys and see how we can leverage the built-in reports and customize and build our own reports. But before we jump to VSys, let's do the final poll. So Dan, if you can be please kind enough to start the poll.
Excellent. Will do, Mo. I think your videos are providing a great insight into the actual workflow. So everyone, this is our final poll before we're looking to move in the final section of the presentation. So the question is, how much time do you spend creating project documentation, BOM, wireless, etc., as a percentage of the entire project time? 3 options here: 5% or less, 15%, or 20% or more. So please just take a couple of seconds here to fill this out and let us know how much time this is taking you. Great. I'm seeing responses trickle in. Again, we'll take another 10 seconds or so just to have attendees fill out. And again, while we're waiting, just a reminder to everyone, if you have questions as Mo is presenting or in relation to the other presentations, please don't hesitate to enter them in the questions app and as part of GoToWebinar, and we will be answering them towards the end or as a follow-up. Great. With that, we will close this poll. In terms of sharing the data, so majority of respondents are looking at 5% or less, but again, we do have decent chunks of the audience that's taking up different amounts of time here. So I'd say with 46% doing it 5% or less, but then 31% having it at 20% or more, we are seeing people across the spectrum here, Mo, which I think will make this next section interesting as it adds value to the people watching. So yes. With that, I'm going to go ahead and close the poll and pass it back to you, Mo.
Thank you very much, Dan. And again, questions, the answers exactly are what we're expecting, because the documentation depends on the project, depends on the size of the company, and depends on other factors as well. So, but the thing in common is that all the attendees who answered the poll, they spend significant time in reporting. And essentially what I want to show you here is that how we can leverage the built-in capabilities to make sure that we do the reporting in essentially as fast as possible and without spending much time on it. So this is the same design that we just saw in the video for the verification. We have all the components assigned, all the part numbers, the bundles are exactly as what we want. So the next step, what we're going to do is we're going to utilize the built-in functionalities and the built-in reports in VSys and view, for example, look at the bill of material that is generated on the fly, generated within VSys. Let's say it's appearing on my other screen here. This is the bill of material of this design created on the fly. It shows all the descriptions of the part numbers or the part numbers of connectors, the descriptions, and how many of those devices used or those components used. Again, the documentation can be saved, or you can print it, or you can share it as an Excel file. it's up to you. The documentation, again, is generated on the fly. Other reports that we can look to essentially for looking at the harness wire list, that is again generated on the fly, and we have all the wire list that is generated. All those reports are built in VSys. They come in off the shelf. You don't have to do anything but select them and print them out. However, if you would like to customize your own report, you can build your own report and add it to VSys, and you'll always be able to print that report directly from VSys. So let's quickly show you how we can create a quick from-to report. We're going to open, and it's showing on my other screen. We need the first column, which is going to be the wire name. I'm just going to include wires. It's going to be an attribute with the name of the wire. Click OK, and a list of all the wires are added with their names. We're going to add another column, which we're going to customize to be the from connector. And we can add even text, say coming from component name. Done. And it says coming from which component. And again, add another column, which is going to be the to column. So it's going to be to, and add the text at the beginning going to. And just like that, we created our the report that we want to create, and you can extend this even to include all the components that are used in the design. For example, in this case, I'm just using it for wires, as you can see here, but I can control it to add connectors, ring terminals, and splices, and so on. Once I've created the report, all I have to do, save it, yes, and now let's print our report that we just created from the report, and it's this one, and view the report, and it's showing in my other screen, and on the fly we can see that this is the report that we just created with the information that we just added. So reporting is very, very easy, very customizable, and you can tailor the reports based on your standards and your company standards as well. So with that, I jump back to my presentation, and essentially what we covered today, all the functionalities that we've seen today are not only limited to the automotive industry, but you can see those functionalities across all industries. So for example, what we saw today in the automotive and transportation company industry, where the same process, the same workflow is supported in both situations for the ECAD and MCAD, where you can cross-select, import, and export the information between the mechanical team, electrical team, technicians, and essentially all team members working on the same project. The same thing could be said in the aerospace and defense industry, where exactly the same idea, the same workflow, and this is the value of the tools in VSys, essentially, where it is customizable based on the project, based on the industry. So the same workflows that you can customize and tailor them exactly to fit your application. And the same thing could be said in the electronics industry, where, example, here we're showing this application where we're using the tools to essentially design the switch gear and the switch box of this device. So the application extends through all industries, whether in the transportation, aerospace, electronics, even in marine industry and heavy equipment, as well as medical devices. So the electrical content is always increasing. And regardless of the industry and the application, this increases the cost, as we mentioned, the time, and every time something new is added, there is a risk associated to that. VSys addresses those challenges by allowing the users to automate the design workflow, collaborate between the different multidisciplinary team, and reduce the design costs. In closing, VSys provides functionalities that help engineers deliver rapid, right from the first time, error-free electrical and harness designs through automation, analysis, and a wide variety of time-saving features. VSys allows design teams to put their effort where it really counts, into innovation. Thank you very much for listening. And with that, I pass it back to you, Dan, where we can start taking in questions.
Excellent. Thank you, Mo, for that wonderful summary and rundown, as well as to our other presenters, Ben and Paul, on their messaging and excellent presentations. There's a handful of questions here, Mo. I'll start by sharing them with you, and feel free to pass them up to the other panelists. First and foremost, does VSys integrate with non-Siemens MCAD tools, or is it just the Siemens tools?
Okay, so that's a good question. So VSys integrates with all major MCAD tools, Siemens and non-Siemens. So whether it was Siemens, we integrate with SolidWorks, Solid Edge, Creo, CATIA, and so on, all the big names. So it's not just limited to the Siemens tools. And Paul, please feel free to jump in if you have any comment, if you have anything to add to those questions or anything I'm missing, please feel free to jump in.
That was a perfect answer, Mohammed.
Thank you.
Wonderful, and absolutely agree. The importance of integration cannot be understated, and Paul touched on it in talking about the digital twin and digitalization in his part of the presentation, but it's great. All right, next, and again, I'll pass it to you. Are there any special license requirements to exchange ECAD, MCAD data? Can you speak to that?
No, the functionality is native to VSys. All you have to do is export the data from VSys and make sure that the CAD system, the MCAD system that you're using, just accepts the data from VSys and VSys reads in back. It's done through standard formats like PLM XML, XML files, and wire list and net list, I guess, for SolidWorks, but no license is required.
Wonderful. And I think we have one more, just bear with me. If I just take a look at this last one here. Can you speak to the scalability of the product? How scalable is VSys and the portfolio in general, Mo?
So the portfolio is extremely scalable, and I would like to defer this question to Paul to answer the one about the portfolio. But VSys, I'll take the one about VSys. VSys is scalable where you don't necessarily need to do the entire workflow. If you just build schematics, you can just build schematics, and you don't need to have the harness and ECAD and MCAD collaboration. If you're just building harnesses, again, you can just have the harnesses. So it's extremely flexible based on your design, based on your company, your industry, and your workflow. That's in terms of VSys. As for the entire portfolio, I'd like to invite Paul to answer, since he is the executive portfolio manager for those types of applications. We call the integrated electrical systems. So,
yeah, I think I mentioned in my section of the presentation that VSys is in use globally. Typically, VSys users sometimes use a standalone, single installation, but more often it's a client-server installation with a floating license. The largest, in terms of scale, the largest customer user count that I'm aware of is 18 floating simultaneous licenses, which exactly, but I would guess that would be around about 30 users hitting up the same database, and maybe at peak times going into kind of usage on 2 shifts. So VSys is scaled to that sort of level for that number of users, and then obviously there's like hundreds of schematic designs and hundreds of harness parts in there. The other parts of the portfolio, I think it's worth mentioning capital. In the larger global implementations of capital with customers, kind of, household names, General Motors, Navistar, and so on, you're looking at, in some cases, hundreds of accredited users with different permissions to go into different parts of the system. Mohammed mentioned the distinction between people doing schematics and people doing harnesses. In VSys, there is the capability that you can kind of mask over one part for users and for the others. In Capital, it's almost ridiculously compartmentalized. For aerospace, for example, Boeing is a user of Capital. There are very strict rules about who can change what, when, and where. So I may be able, and Mohammed may be able to access the same schematic in Capital. He may be able to, rework the wiring specifications, but I may be denied permission to touch them. There's that kind of granularity. So there's very large scalability, and in the Capital world, there's even cloud-based hosting manifestations of that product, as big as you like. But what we've been talking about VSys, the upper limit number of users that we've seen out there in the field is a use case of about 35 engineers using it.
That's great insight, Paul. Thanks for the detailed explanation there. And building on what Mo was discussing. I have one final question, and I'll pass it to Mo, and I'd actually love to hear from Ben on this one. And the question is as follows: how do I get started if I wanted to explore VSys for my team or organization? So Mo, why don't you take a first stab, and then I'd love to hear from Ben.
Definitely. So we're always available to help you investigate VSys and help you throughout your evaluation period to make sure that VSys addresses your needs from a technical standpoint. And without taking much time, I'd like to pass it to Ben, who has been through the process with us, and I would like to get his remarks on that process.
Hi, Mo. Well, I think that the first thing that was, I'm sorry for that, that was really beneficial on our start was the time that actually Mohammed took with us, and Paul as well, just to explain the capabilities and the basic things to do and how to try. And then on the Siemens website, there's all the tutorials as well to start with. There's really a ton of information to get you started and really move on and go forward in the testing. We spent, I think, 3 or 4 people at the office that tried it for about a month period. So it was pretty interesting time. And we spent a lot of time with Mohammed on asking questions and trial and error, and that's the way we worked.
Excellent. Really appreciate that candid response there, Ben. And Mo, thank you for chiming in. Once again, I'd like to thank all of our presenters here on the great topics that they put together. In addition, I'd also like to thank all the attendees for staying and getting and looking at this deep dive that we put together. So as mentioned, if you're looking to get your hands and test out the tool or learn a little bit more, do a deeper dive into your use cases, please do get in touch. I had mentioned this is an invite-only series, so if you'd like more information or you'd like to follow up, please do get in touch with your account manager or whoever had sent you the invite to this presentation. If you don't know who to talk to, we have a colleague of ours, Matthew Dupuis, who would be available as well. You have his email there below. Please feel free to send him a note. You can even send it to info@myHGT for us. As long as you're finding ways to connect, that's great. I also mentioned that the recording and the presentation material will be made available, so you can expect that in the coming days. And we really hope to see you in the next presentation next week, where we look into demagnetization, again, this time with Professor David Lowther, co-founder of Infoletica. So thank you to everyone once again. I hope you have a great day, and we look forward to being in touch. Bye now.